You know what time it is. We're gonna go live. I need to get out of some of these. Then we can discuss what we are working on. Nutrify. Are we live on the Twitch? Do I sound all right? Boom. Looks like we are. Okay. So if you're joining into the Twitch, let me know if you can hear me. As always, let me know if you can see what's on the screen. Do I have too much going on here? No. So we want to... Today is... What's today? October 22. So let's open up code. New. Today. Get rid of all this. Can you see this? October 22, 2021. Today we want to explore USDA food data API. We can also test the API. Let's see if it works. I think the latency is too much. So essentially what we want to do, we might have to rework this project outline, but that's okay. What do we have? Oh my goodness, we have a lot of changes. What branch am I on? Let's first clean up the repo, hey? Because I've let things get a little too out of hand. Siobhan's, I'm back, my friend. Hello, Hasminator. Team, I've had a huge couple of weeks. I haven't been on the stream in a couple of weeks, but that was because friends had some weddings, and then I had other things on, but we're on. So we're gonna really dive into this project and a couple of other things that I'm working on at the moment for the rest of the year. So you might have seen on my GitHub, there's a new profile picture. You can see that of me most places. I haven't updated my Twitch photo yet. Let's tweet this out, since I haven't been on Twitch in a while. But we're gonna have a fun stream. Just create an amazing product and users will find you. So let's go. Going live on Twitch. Doing exploratory data analysis on USDA food data. United States. I hate it when people do like a little United States Department. How do you spell department? Of Agriculture. I hate it when people just put the acronym and people don't know what it is. Agriculture. I can't spell. Food and nutrition database. Let's get a food emoji there. Food. Oh, I can't do it there. Wave. Now we're going to use good old-fashioned pandas because the data that we can get is in twitch.tv/Mr. Debo. The data that we can get, boom, live on Twitch. Okay. Thank you, Hasminator. I should have linked their page. Oh well, it doesn't matter. They'll be fine. So let's have a look at what we're building with Nutrify. I'm working on 2 things at the moment. This is going to be for the rest of the year. Nutrify and PyTorch. That's what I'm doing. We need to clean up the GitHub repo. So let's put this down. So clean up GitHub repo. Review outline of project. So if we go to Whimsical, Siobhan, I've also seen that you've done some amazing work in the pull request. We probably have to check that out. I need to sign back in. Is this going to ask me to? Don't ask me for a password. Yes. Oh, thank you, Hasminator. 97,777. Yeah, so this is what we're doing. Yes, this is what we want. So we need to create this database because the food vision model, we can do the model. I've got images. We're going to do another stream in the future or plenty more streams of modeling. Today we are trying to build this. And this is where we get it from. I think I'm going to use this. Food Central. So let's, because look at this. We have, this is for a steak. Each food has a food ID. So if you want an overview of what we're doing for Nutrify, this is what we're doing. We're taking a photo of food. We store that food. We've built this already. We've built this. It's in Google Sheets right now, the metadata about food images. So eventually that'll have to go to SQL or something like that, but that's all right. We can convert it from Google Sheets to SQL later on. We're going to build a computer vision model in a future stream. At the same time as you take a food, that food image is going to go through a computer vision model, return what it identifies as different type of food. Then the image ID gets referenced to a database and the nutrition information for that food gets displayed. That's the ideal workflow. However, of course, we need to create a database for all of these things because the computer vision model will take just images, basically. Images of food, labeled images. However, when we identify it as a pizza, cool, it's a pizza, but I want to learn about what the nutrition information about it. And of course, it's going to be different for every pizza, but we'll just start with a high level food. So we're going to be working on this, and I found an open source database for all of this stuff, which is FoodData Central. You can download all of their data. So this is what we need to explore. We need to see how we can, I've tried out their API as well. However, it takes far too long to respond. 1.8 seconds. Look at this. So if I do this, I've got an API key. If I want food, that's its food image key. We reference the API at the USDA.gov, which is the United States Department of Agriculture. And we put in the demo key, reference a specific food, and we get back all of this information here. So we need to figure out how we can put this in our own database and reference this pretty quickly, a lot faster than 1.8 seconds. Well, look at this. 2.29 seconds. That's not ideal. We want that to be faster. Yo, Sheik, how are you? Welcome back. Hasminator says, are you going to be using PyTorch or TensorFlow to build the model? I haven't decided yet. Might do both and just see which one performs best. So let's figure out, I'll show you where I downloaded the data from. Here, FoodData Central, download datasets. So let's go back to where we were. That's the dataset that we downloaded. Clean up the GitHub repo. Let's get a terminal here. I'm using VS Code notebooks now, by the way, because they're really cool. Git status. I'm on the main. Let's add the data exploration so you can see this. This will be on the git commit add data exploration. Check for large files. I want to turn off. I want to add those large files. That's okay. They're not that far over 500 kilobytes. Yeah, they're only about, the biggest one's 16 meg, and even that's not too bad. And so there's also a data dictionary to go along with it. So let's open that up. Now this is all part of building a data set, team. So this is telling us what's going on in each database and each. Let me just show you what we have. We have a whole bunch of different CSV files here that we've downloaded from the USDA, and we want to explore them and try and link them. They all have a unique food key. So that's probably a question for Twitter, is in designing a database, how many columns should a database have? 2K subs needed to hit 100K. We're getting close. What should I do for 100K? Who's got ideas? 100K on YouTube. Who's got ideas? Yeah, so this is the global column definitions. FDID, which is the food identifier. And then thanks, Siobhan's. I'll figure out, yeah. I can't even remember which file we used to add that functionality. Pre-commit YAML. Here we go. Where's the file size? Check added large files. What if I just comment that out? I'll just comment it out for a second. Hey, Elemental Strife, what's going on? Thank you for the kind words, my friend. Great to hear you learning ML. Add push. There we go. Okay, so the data explanation's now on GitHub. You can see it under Nutrify. There. Data exploration. Clean up repo, that's good enough for me. Tick. Review the outline of the project. Let's make this a bit better. So we'll get this logo. Text, and then we can go here. Yes, so this is what we need to do. We need to format this. So what we're doing right now, Samantha, what's going on? We're creating a nutrition database. We're exploring some data from FoodData Central here. We've got a whole bunch of CSVs here, like with millions of rows. And we want to set up this project. Before we even get into any machine learning, we need to set up the bits and pieces around the machine learning. We need to create a database, because once the machine learning is in place, if the database is good, the machine learning part we can automate. So that's what we're going to be working on today. We've updated the workflow. Let's tick this, and now we're going to have a look at the data sets. So we've got a notebook here, standard imports. This is going to be rough for the foreseeable future until we improve it. But we have, this is our food. Look at this. Look at this information that we have here. FDIC, sample food. So the food unique identifier. And then we have hummus. However, what I found is that there's if we look at the unique descriptions, there's 11,000 here. But we obviously don't want 11,000 foods to begin with. We want like 10. So that's what we're trying to do today is probably, let's write that down. Today, too much zoomed in. Clean USDA food data to find 10 different foods. And then we want make database of these foods. Simple data frame to CSV. Once we've got 10, then we can increase it from there. And which 10 are we going to find? Let's get up the Food Vision database, TensorFlow course. What did we use for the 10 food classes? This is the 10 foods we're going to try and find. Chicken curry. Why these foods? Well, it's because I've got food images for those different foods. So we want chicken curry, chicken wings, fried rice, grilled salmon. This is a fun part, team. We get to make a database. And then we get to go to the machine learning. Hamburger, ice cream, pizza, all the code's going to be on my repo, by the way, Nutrify. I want to build this whole thing in open source. There we go. The data will probably be a bit hard because I've got close to 800,000 food images so far. We'll get to that in another stream. But storage is cheap. It's that if you make like them downloadable, that's what costs you. Like the transfer cost with storage, that's what costs people. So you can store like a terabyte worth of data on Google Storage for like $10 a month. But it costs, if someone downloads that terabyte, it costs like $3 every time someone downloads it. So you imagine, or maybe more, I don't know. But, so these are the foods we want to get. If we go to unique descriptions, look what happens. We have like 10 different versions of hummus. That's what we have to figure out. Where do these descriptions come from? Where do these descriptions come from? How can we reduce them down to like 10 unique foods and keep it simple? Gaurav, what's going on, man? No, you're not too late. I've only just started. It's only been 20 minutes or so. I'll go for a couple of hours today. Hide the sidebar. What do we need? Let's just figure out the bare bones minimum that we can get for, see, there's a table in here called food nutrient. Average amount, which says nutrient ID, but then, see, this is the thing, I don't know with databases, the way they've structured this database is they can all be connected by the FDC ID, which is the food unique identifier. But all of these different databases have like only 10 columns per thing. So I don't know if that's the best way to structure things, but let's figure it out. Nutrient, there we go. Okay, let's open up the nutrient database. Because these are the different foods that they have. Description, dairy and egg products, spices and herbs, baby foods, fats and oils. Look at this. This is very exciting. Vegetables and vegetable products. But the 10 foods that we want is, let's write this here. 10 foods we want. To keep things simple, we will reduce the databases from FoodData Central. Is it called FoodData Central? FoodData Central, yes. To 10 different foods. Why these foods? Because we have images for those foods ready to go. Okay, and the 10 foods are and we'll create 10 foods. We're getting somewhere with this team. Why won't that go into Markdown? Escape. Escape. Why? Ice cream. Oh, Python variables can't begin with a number. Is that correct? Look at me. Python novice here. Let's format this so it's a little bit more Pythonic. I don't even know if these foods exist in the database, but we're going to see if they do. Change this into code. And we want to get the import nutrition database. So this is what I was saying. Right now, all of the foods, ls, cd, data exploration, ls data. So right now, all of the foods are in 2 folders here, but they're all CSVs. Data exploration, right? So we have all of these CSV files. We want to import them into pandas and explore them. I haven't seen any of these, by the way. So let's just go here. Nutrition equals PD read CSV. We'll just start exploring. We'll get the data keys up in a second if we need them. Pass in the file path. How do I copy that file path? We want just data and then nutrition.head. This is very exciting. Hey Eric, what's going on? Gaurav, what does the data contain, by the way? It contains heaps of data from FoodData Central. So this is what we're figuring out. Hey, Alessandro, what's going on? Hey, what do you call it in Italy? Italiano. Hey, Italiano. So the US Department of Agriculture has a FoodData Central with just a whole bunch of data. There we go. It's an integrated data system that provides expanded nutrient profile and links to related agricultural experimental research. So this is what we're after. We're after food data because we need something to reference off. For once we identify foods. So let's go back. Ah, there we go. Beautiful. So how many different nutrition? Oh my goodness. We have 463 rows here. Let's view the first 20. Italiano. Italiano, Italiano. Archived. Beautiful. Look at all these. So we probably only just, let's reduce the search space again. So we don't want 463 columns to begin with. We probably want protein, fat, carbohydrate. We'll get nutrition. We'll go nutrients equals nutrition dot unit name dot unique len nutrients. Why didn't that do that? $12? Oh no, name, not unit name. Hey, thank you, Eric. I appreciate that. Now let's have a look at, yeah, look how many nutrients we have. So this is, I want to highlight how important this is at like building a data set. It's just figuring it out. I actually don't know how this is going to look. So I imagine it is going to be, let's imagine it. We want a data set. Data set looks like we'd have food ID column, and then we'd have, so we've got 1, 2, 3, 4, yada, yada, yada. And then we'd have nutrient 1, nutrient 2, nutrient 3, nutrient 4, etc. X, Y, Z, K, and then so on for the rest. So I think that's a good way to start, don't you reckon? Or, yes, that would be just the amount per. How about we start off by getting the amount for each of these, because we have a lot of files here that we can add more data later on. Sample food. Okay, I think that's what we're going to build today. We're going to get a little table like this, food ID, and then we'll have, say, protein, carbohydrates, fat, and then something else. Oh, we don't even need 4. We could just start with 3, proteins, carbohydrates, and fat. And then we want the amount per, what do they store the amounts in? Food. But then if we come up to the food portion, yeah, food nutrient. Okay, we need this database as well. Food nutrient, nutrient ID, so that's indexing on here. That'll index on this one. So you're seeing how this is starting to be structured is they've got like a lot of little data sets. Well, not little, but they all index off each other off different IDs and column names. Now, I'm not a database expert, so I'm not sure like what the best way is to structure such a database. But I've heard it's efficient if you just have one unique key throughout all of it and then create small subsets of databases and only use what you need when you need. So the amount of the nutrient per 100 gram of food, beautiful. That's what we want. So we're going to need food nutrient. So this is nutrition. And let's get food nutrient. Food nutrient. Read CSV. What's the other one called? Did we call it the right name? I want to keep them in the same name, the data frame in the same name that they use. Nutrient. Okay, we need to change this one to nutrient. Nutrient. Okay. Yeah, Siobhan, you're right. So Siobhan's is saying about databases. So if you're working with a relational database, which we are, a relational database, I understand it is just rows and columns, so like Google Sheets. And then you'll have one column. It's actually like the database for Food Vision, for Nutrify. The database we're working with right now, our production database is literally a Google Sheet. Test upload. So this is a relational database. You'd have one unique key. This is for images though. So we'd have another unique key for foods. And then we would say, for example, this was a hamburger. We would then go, okay, the model identifies the image as a hamburger, which is image ID, which is food ID. Hamburger gets mapped to say food ID 1. And then we go to our nutrition information and go, okay, tell us what food ID 1, tell us the nutrition information from that food. So that's what we want to build. Let's do that. So we need to clean some data. We'll change this. Food nutrient is going to be food nutrient source. Nope. There. And then we're going to pass that in here. By the way, I'm going to make more like YouTube worthy versions of this series. Nutrient. Oh, what's happening here? D-type warning comms have no. Which one are we getting? See, that's the thing I don't like about VS Code notebooks. I don't know why it creates a new cell at the start of a notebook. Because I press escape here, I'm on this cell. If I press B, wow, okay, it didn't work that time. So now let's have a look at food nutrient. Okay, there we go. So here's where the food gets indexed on the food ID. Do we have food? We want to call this the food data frame. Maybe we bring all the imports up to one place. How do I move this up? Where's the up button? Execute above cells. What's the shortcut in Jupyter to move up? I'll just copy it. So these are the databases that we need. Yeah, Alessandro, I think I like native notebooks better still. VS Code notebooks feels like it's got a few bugs, but we'll just keep working with this. Jupyter itself is a very clean, like coding environment. It feels good to code in a Jupyter notebook. Of course, you can't ideally do many of the things you do in a IDE, but Jupyter is fast at what it does. Import databases. Okay, we've got some databases now. Now let's have a look at all of them. Food.head, B, escape, B. Now, nutrient.head, did I spell nutrient wrong? Nutrient. And now we want okay, so we have a few different databases here that are linked by food. Let's move this one. Give me an up button. So the food database is linked on food nutrient by the food FDC ID. And then we have the nutrient ID is linked here between nutrient and food nutrient. So let's first get our 10 favorite foods from the food database. So we need to find in description food.head. So its description column has all the food names. Unique food names, and then unique food names. Okay, we need to filter these in some way. Unique food names. We need to clean up these strings. Yeah, because see, we've got, How many of them are there? $13,000. Okay, that's not too many actually. I mean, 11,000. Oh, no way, Shavans. This project's not going stale. I just had a few things on in real life that sort of I just needed to devote attention to that 100%. Now for the rest of the year, I'm devoting attention to this 100%. And of course the PyTorch course. So let's figure this out. So we have a list of these. However, I doubt that like chicken underscore curry is going to be in unique food names. So let's go for name in unique food names. No, let's go chicken list. Let's just do something easy. Unique food names. If name dot contains, is that a thing? No, in. If chicken in name dot lower chicken list append name. Chicken list. Float. Unique food names has a float? What, son? Name dot string. String has no attribute string. Aha. There we go, team. Look at that. How many chicken items do we have? We have 1,200 chicken items. Good Lord. Okay, so we need to do some formatting on these. Look at this, non-enhanced. My God. If chicken thank you, Alessandro. We've got some lasagna in there. Delicioso. Drumstick. See, this is going to be a little difficult to decide. They call chicken... So this is another thing we got to figure out. Do they call chicken drumsticks wings, or do they call chicken wings wings? And eventually, once Nutrify gets bigger and whatever, we can create our own database. But for now, we're going to start with this. So let's do if chicken and wing in okay, so none of them have wing in there. What if I just put wing? Hey, wing. Okay, so they call chicken, what do chicken drumsticks look like? This is what we're going to have to get semantic search. Yeah, look at that. They say chicken drumsticks is that. And if I look up chicken wings, yeah. Drumsticks, wings. Yeah, okay. So they're probably calling the same thing. For me, a chicken drumstick is bigger than a wing, but by the data set, there's wing. They only have Wing Wong Barbecue, Florida. They don't have chicken wings in there. So let's just get a generic chicken wing. Why do we have so many? So we want chicken and drumstick. They spell drumstick, drum. Chicken list. Okay, here we go. We're getting somewhere. How many chicken lists do we have? There is... Hold on. There is 1,200 types of chicken drumsticks? Oh, so that's a type of chicken. Okay, I'm starting to get how they've structured this database. Let's go to their website. FoodData Central. Chicken. I can index on data frame by going let's go food, and then we want food and the column to be description dot contains chicken dot string dot lower dot contains is my pandas right there? I'm not set on the name Nutrify, but I like it. It also doesn't really matter, like if someone's taken it. Like there's heaps of... I've got a pretty good domain for Nutrify. Pandas check if a column contains string. Oh, it's not a function, it's a method. I mean, attribute. Pandas filter rows if column contains string. Yeah, I thought I was doing it right. Oh, remove nans. I need to drop NA. How do you quickly tell food.is NA? Pandas. I'm going to just get rid of the NAs for now. How many had NA? Oh, only 30 rows have NAs? Come on now. Just going to drop the NAs. I don't know the legality around naming either, but hold on. all strings in column. Pandas, I'm doing what you told me to do. Am I missing something? Eric says, did I get this wrong? Thank you, Eric. I could have sworn that would have worked. Not DF, my bad. What? So we have food. We want to check on a column. What happens if I just lower? Something has to be wrong here. I swear this would have worked. Yeah. Did I not do this? The number one upvoted answer on Pandas is not working. I mean, Stack Overflow. I hate that from this notebook. This is... DF df ids dot string dot contains. Why is this not working? That works. So I need to lower it first. sr.string.contains pattern is. Case, oh, if true, case sensitive. Oh, let's turn it off. Hey, thank you, team. Just look up the docs next time, Daniel. I knew that was doing that correctly. We just can't lower it first. Okay, but we should probably pre-process the text. We should lower it all. There we go. We've got 1,200 foods. We've got some IDs here. Drumsticks. Tuna, chicken of the sea. The tuna, if you didn't know, tuna is actually the chicken of the sea. Ali Lamb, yes, you're so right. 5 hours of debugging can save you 5 minutes of docs. That's hilarious. I want to tweet that. That should be a tweet. Is OOP that necessary for machine learning? Like eventually you're going to start writing OOP code. It's not 100% necessary, but eventually you'll start to write OOP code. Well, you can write, actually, the new machine learning framework, JAX, I believe is completely functional. So take your pick. Let's now figure out what the hell. I want to double filter this. I want to filter this down. Can we go? Can I have an and in here? Nah. Oh, maybe I can. I haven't used pandas in a while. Pandas, filter, data frame on multiple conditions. This website's too... Oh, there we go. And. Oh, of course you can. I thought so. And food description. Let's get all of the ones that contain drumsticks. Gosh, I love pandas. I just want chicken wings. Key error. Can I do 10? There we go. Thank you, Eric. Oh, wow. Pandas is in. I'm going to like that. Am I signed into Substack? There we go. Okay, now I want... What is going on with all of these different ones? We go back to food database. Chicken. Hey, here we go. Meat only cooked braise. Breast. Chicken, broilers or fries, drumstick, meat only, cooked, braised. All the best to Sheik, enjoy. What Dan love? Pandas and maybe some chicken wings. Okay, so this is what we want to get from chicken. Does this make sense? Protein, 23 grams per 100 grams. Yes, that makes sense. Okay. But why is there 7 million examples of chicken in this database? Food ID 331897. What does that come up in where we're working with it? Data type, foundation food. We just found it, team. We just found it. We want only the ones with foundation food. We don't want sample food. We don't want all this junk. We just want foundation food, and then we can index off that. Let's get foundation foods. And we want foundation food equals. Now, do we have a description for this? I love data analysis. Exploratory data analysis. First I thought we were going to have to do so much filtering, but now it just completely makes sense. Foundation food. That is in data type. Data type. See Files tab. Where's Files tab? Files. Foundation food. Here we go. Foods whose nutrient and food component values are derived primarily by chemical analysis. Foundation foods also include extensive underlying metadata, such as the number of samples, the location and dates which samples. Okay, I think we can deal with this for now. Let's go back and we'll index on foundation foods. Foundation food. Foundation food is the ground truth for a certain type of food. Excludes some details about the food, e.g. The data type foundation food for chicken will be the original unique ID for chicken. Yeah, Siobhan, that makes sense. They buy the food, chicken wings, and they cook it in different ways. So what they do is they buy the same food at multiple locations on different days and build a more representative samples. Yeah, chicken wings may be off at one day and one location. Yeah, I think this is what this database actually does, is they have many different types of the same food, but then they average it out. Samples, yeah. So there's multiple different samples for this. So if we go to protein, samples. Yeah. Okay, so this is just the average of multiple different samples. Okay, this is very cool. See here, Siobhan's, if we go here, I think they've done a similar thing. So see how some of them are slightly less. Then they've just got the average. Protein. So they sample the nitrogen. Wow, that's pretty cool. So the protein is 6.25 times the nitrogen. Didn't know that. Wow, that's how they calculate nitrogen. Yeah, we could eventually collect a representative from different countries. But for now, I'm just going to keep it as simple as possible. We just want protein, total fat, and carbohydrates for any given food, for 10 given foods. And then once we finish with that, then we'll go from there. So foundation food equals food. Food, we want data type equals why does it creates a cell at the top of the notebook? I don't get that. Here, look, escape, B. Wow, okay, it works then. Food, data type. Okay, so that's what we want. We want foundation foods. Len Foundation food to filter. 195, wonderful. That could be our first goal of building a model to understand and identify the foundation foods. Oh my gosh, team. Yes! Look how exciting that is. We've got 195 foods. That could be our first model goal, is to build a computer vision model for only the foundation foods. I think if we had a computer vision model for all of these foods, that would be a pretty cool model to begin with. Of course, it can go further, but a foundation food, that's 195. To me, how many different foods do you eat on a regular basis? I mean, chances are they're probably within the top 100, right? Let's go foundation foods. We just got a list of foundation foods. Ladies and gentlemen, this is what we're talking about. We can build off this. Foundation foods. Let's read through these. Dot 20. Frankfurter, milk, low fat, nuts. We could condense these. Egg. Oh, yes. Whole, white, egg white, dried, sauce, salsa, sausage, onion rings, pickles. Let's go the next 20. Peanut butter, cheese, grapefruit juice. Of course, this is all westernized, but we can work with this to begin with. Kale, carrots, mustard, figs, kiwi fruit. This is so exciting. Let's again. Right at the top. Foundation foods. This will be our goal. The first goal of Nutrify is to take care of the foundation foods, a computer vision model that understands the foundation foods of this database. They're 195. I'm going to shorten it to 100. Like that's the prototype of Nutrify. If we can get it to work for 100 foods, then we're onto something. We can slowly start adding more and more as it goes. I'm so lost in this notebook. Foundation. I feel like playing some music and dancing. Foundation foods. I want another cell here. Let's go foundation foods. 30. Okay, 30 to 100. How many can I visualize here? 50 to 100. There we go, team. Open raw data in text. Beef loin. We've got a steak. We've got beans. We've got bread. Oh, yes. Look at this. Carrots, cheese. Okay. Let's now filter these a little bit more. We've got the foundation foods. Maybe I'll go to 100 and 150. What else do we have? The good thing is that they're all whole foods too. Oil. Yeah, so eggs grade A, like we can filter that out. Like a large egg it's not too dissimilar from a small egg, if you know what I mean. It's not going to be like outlandishly. We could provide a range for certain foods. Cheese, figs, lettuce, milk. Chinese sweet and sour pork is a foundation food. Foundation foods. To list, is that how you do it? List. There we go. We're on, team. This is our list of food we're going to tackle down. Mushroom. See, we could just do one mushroom to begin with. We could do one apple to begin with. There's 10 different kinds of apples here. Spinach. Garlic. Beautiful. Bananas. Butter. Flour. Pork. Oil. Beans. Heaps of different beans here. Milk. Sausage. Lots of beans. More beans up here. See, I would even add some things to this. But this is where we can start. This is an interesting list, actually. I wonder what's in... So that's a foundation food. What other data types are there? Foundation food. No. We want food. Data type. Oh, food. Data type. This is the power of exploratory data analysis, you know? We want the uniques from this. We've got a sample food. We've got market acquisition. And we've got subsample food. What's a sample food? Oh no, we don't want that. Sample food, food. Okay, 1,900. So we've got different types of description. Okay, how many do we have here? Sample foods. We have 1,000. Let's put that into a list. Is that already a list? Let's go list. Wonderful. Sometimes I think about you. So we have 1,000 different subsamples of food as well. So we're on here. We are on here. We've got enough. That's enough foods to begin with. Almonds. There we go. Egg. Look how many different types of egg there are. Salsa. Onion rings. Pickles. Peanut butter. American cheese. Different brands. Oh, yes. Grapefruit juice. Peaches. Sunflower seeds. White bread. Carrots. Mustard. Oranges. Lettuce. Cheddar cheese. Cottage cheese. Egg. Greek yogurt. Oil, ground turkey, chicken skin, sauce, pasta, pears, lots of pears, tomatoes, pollock, tuna, beef, lots of beef, McDonald's American cheese. Hey, okay. So, let's just move on to where we were before, back to where we were. We want to, from the foundation foods, we want to get the 10, we can get rid of that. DMC free music, where do I find that? So let's unique food names, foundation food. Nope, that's what we want. Found a list of the foundation foods we're going to start with. Wanted Sam, what's going on? Nice to meet you, my friend. Nice to see you here. Thanks for joining in. We can get rid of this, unique food names. We can also get rid of this. Can we? Do we have chicken in foundational foods? Let's just copy that or comment that. Find chicken in foundation food. For food in foundation foods list, if food.lower if chicken in food.lower print food. There we go, we're on. Okay, foundation food, let's can this. So we're going to need, let's have a look at our foundation food data frame. We're going to need to, let's get the ID for chicken drumstick, because that'll be our chicken wing. Foundation food can be, we want a text-based way of searching this. Flyboy, good to see you joining in. We are building Nutrify. I'll send you the GitHub. You can link that there. But essentially, we're building a data flywheel to take a picture of food and understand it. This is what we want to build. We want to use a smart device to take a photo of food. We want to store that image on some database. Then we want to run a computer vision model over that image of food, identify what food is in that image, such as pizza, and then we use that pizza image ID, send that to a food database, which is what we're exploring now, and figure out the nutritional value of that food, and then send it back to a device. So what we're doing now is we're building that database of food images and nutrition information about certain foods. And to build said database, we are using FoodData Central, which is from the US Department of Agriculture. This stream is all about filtering the data that they offer. You can download it. So I've downloaded the data. Now we're filtering it using pandas. And this is what we found so far. Foundation foods. So, foundation food. My boy Eric said you can use is in. Foundation food description dot is in. Do we have chicken? We need a string here. I mean a list. There we go. And we want this ID here. So let's take this ID and see what we can do with it. Let's get 0. Lock. There we go. I lock 0 and we want FDC ID. Chicken wing ID. Wonderful. Okay, so we've got the chicken wing ID. We want to turn that into an int. Okay. Alessandro, what do you mean by a separate job to keep training? The model will always be training. Like once I've set up a small database and got like the overall workflow going, like the model will always be training. Like as more and more data and more images get added to it, will create like just high level, just use some larger models to sort of just continually label food images, and then we can start to work on the back-end database as the model's learning more. But this is all a work in progress. I don't know how it's going to look in the end. That could definitely change. So now let's take this. What data tables do we have? We want food nutrient. Food nutrient. Now let's get food nutrient. Flyboy, I'm in Australia, so my time zone is GMT plus 10, Brisbane. But I don't usually have a stream time. So if you want, you can go to the archive channel and all the VODs should be up on there. Based on the imagery, but I saw a separate workflow to keep the model in training. Oh yeah, I haven't worked out the training pipeline yet, but we'll work it out as we go. I need to do some. I've got a lot of images downloaded. I need to do some EDA on those later on. But right now we're building this to work for 10 foods, and then once we get a small workflow going, then we can really start to crank up the modeling. So like as more images, unlabeled images are getting uploaded, we could run some self-supervision over the database. I don't know how that works, but we'll figure it out. This is what full stack ML is about. So food nutrient, then we want FDC ID equals chicken wing ID. There we go, 95 different nutrients in a piece of chicken. Holler at your boy, but we only want protein, carbohydrates, and fat. Let's get that. Get protein, carb, fat IDs. So we want nutrient. So carbohydrate by difference, what different carbohydrates are there? So let's get nutrient, and we'll filter on there. Nutrient name string contains protein case Yep, I'm definitely winging it. See, for me, the overall structure of the workflow, once we get the workflow small, that's what we need. Like, we need to do that. Like, scaling up to me is like just turning on more compute and whatever. Of course, it's a lot more complicated than that, but we need to just get a prototype workflow in place and then it can just be an iterative process. Once you have the data flywheel in motion, it's about figuring out, okay, the data flywheel is going. We have images coming up, we're modeling them, we're returning nutrient information back from them. Okay, we have a whole bunch of images that we don't have information for. Let's fix the nutrient database on those images. Oh, we have a whole bunch of images uploaded that we don't have. Our model doesn't know what they are. Let's add more labeled images for those. And it's just a repeated iterative circle, but it's hard to think about what to actually do if that flywheel isn't working. Like for example, Tesla's flywheel, if we go to what we're basing this off, like each one of these parts is dependent on the other, right? So you're not going to be able to train a model if you don't have a data source, and you're not going to be able to find inaccuracies if you don't have a model. So you need each part of the puzzle in place to begin with, so you can work out, okay, we've got all this data, but our model's not powerful enough, so we need to upgrade the model. Oh, we've got all these inaccuracies, but our data labels aren't where they need to be, so we need to increase our data labels. And of course, you need to increase them all at the same time, but without the flywheel in effect, all you have is, like a lot of projects, are just a static database into a model. And so the model never really improves too much, because like ImageNet is just a static database of images. It's not changing. So you can iterate on the model, but all of the other parts of the puzzle don't change. So ImageNet is great for benchmarking, but it's not a full-blown machine learning application. So we need to put all of these pieces in the puzzle in a hacky way. I'm winging all of this. I don't know how to build this data engine, but I'm figuring it out. So then once it's in place, we can go, oh shit, our data source isn't working. Oh shit, our model isn't working. Oh, we actually don't need that big of a model. Like if it works 90% of the time, it's good enough. So yeah, that's a high level overview of what we're doing. So I'm literally just building the smallest possible version of the data flywheel I can, so that we have something that resembles the overall architecture in production. Plus, modeling's the fun part. I mean, it's all the fun part, but let's get fat now. All we want is 3 nutrients for 10 foods and a computer vision model that can model those foods. That's what we're building. That is what we're building. That's phase 1, 10 foods. The master plan is on the GitHub repo. How do you do that line thing in Python? Line? Like that. Oh. Oh no, or. Can I use or? What's the pandas equivalent of or? Is it this? There we go. Okay, here we go. We're on. Is the master plan still on GitHub? There we go. Build food image collection app. There we go. Stage 2. Stage 2 is build a small prototype computer vision app, take a photo of 10 different foods and return back their nutrition information. That's the master plan. The master plan is literally here. I wrote this a month ago. Stage 3, merge inputs into stage 1 and 2 into a database. Start linking together the data flywheel, more images get taken, model gets improved, more images, better models, etc. Stage 4, upgrade stage 1, 2, and 3 to work with world's 100 most commonly eaten foods. Start with the top Pareto curve and then start working backwards towards the tail. Repeat the above until almost every food you can eat is covered. So there's the master plan, people. If you want that, that's in the repo. It's been there since almost day 1. Now it's just a process of doing it. So we have carbohydrates. Okay, we need to look at the database. What is the difference here? We've got protein, we've got many different kinds of fat. We've got carbohydrates. We've got like 4 different types of carbohydrates. We've got about 30 different types of fat, or 20, 15. Oh my gosh. Virgos. That is so cool. Well, there you go. If you want the repo, all my code's there. You probably have a better version of it, but that's really cool. Siobhan's. That is wild. I want to take a screenshot of that. Someone clip that. Look at this. Clip this. I don't know how to make a clip, but we just have Virgos. What are the chances? For my school project, we are making the exact app. I clicked on your stream and saw the USDA API we are using and lost my mind. What the hell? I need to take a screenshot of this. Did someone clip that? How far are we into the stream? I'm going to clip this in a future YouTube video. That is crazy. What school are you from? 137.10. $137.10. UTD. I need to look that up. That is absolutely hilarious. I love that. If someone can clip that, I don't know how to do that. That would be really cool. The fact that someone from UTD showed up in the chat and is building the exact same app. I love that. UDT. University of Texas. Oh, I love Texas. I don't think I've been to Dallas though. I went to Austin. That is so cool. Christopher, you've got an app that's based in Australia that's doing the same thing. Look at this. Ben Alexander. What? Oh, no way. I know this guy. This is wild, team. The Alfred app. Hey, they're on the App Store. I gotta try this out. This is wild. Elemental Stripe has clipped it. Thank you so much. We've got a clip here. I'm gonna watch that later. This is amazing. I'm going to reach out to them, download on the App Store, open the App Store. Good, we've got some competition. Okay, yeah, so they do it behind the scenes post-processing. I like that. I want to have the computer vision running real time in the app. All right. Thank you, Shavans. I appreciate that. First time chat from L Raxon. How often do I stream on Twitch? Fairly often. Probably towards the end of the year, like for the rest of the year, it'll be at least 2 to 3 to 4 times a week. I need to thank you, team, for sending me all of these resources. This is great. Bookmarked. I love this. UTD. Virgo says it's a very cool idea, not going to lie. Yeah, I love this idea. I want it to exist. That's why I'm building it. And I love the fact that other people are working on it too. Like, that's the thing. That's actually a good thing. People, like, if people find that someone else is doing something, they're like, oh, someone else is already doing it, we might as well stop. Just think about how many different car companies are there? How many different cell phone companies are there? You can buy like the 10 best smartphones are basically the same thing, right? Well, of course, like Apple and Google are probably making, and Samsung are probably making like the best, but they all they make calls, they connect to the internet, they do very similar things. So it's like, there is room for even deep learning. There's TensorFlow or there's PyTorch. Basically do the same thing, just different flavors. So let's figure out how we can build this, and we'll open source the whole lot, and then people can jump in and use it if they want. Imagine an API that's just like the Food Vision API. You can just send whatever food you want to this API, and it'll just send you back all this information. That would be the end goal of Nutrify. So let's go back to filtering this data set, and that is, okay, how do we combine these different protein? So protein's on its own, that's okay. Total fat, I think I'm going to get total fat. But carbohydrates by difference, by summation, by other. Let's go to the example of chicken. Chicken. Carbohydrates by difference. What does that mean? Carbohydrates. I'm going to bookmark this for later. Thank you for clipping that, Shavans. I wonder how you could think when your idea is not unique. How to respond. Well, put it this way. If your idea is not unique, if more people around the world are having a similar idea, it means it's probably holding some water. As in, if people we just had someone from Texas, from America, another one from Australia, which is kind of wild that like Ben Ash, like, what's his name? It's a rugby player, is doing a similar app from Australia. I no doubt there's other people working on something similar as well. MyFitnessPal example. Only reason I'm working on this is because I'm interested in machine learning and I'm interested in food. So I'm just combining the two. But if your idea, if many other people have a similar idea, it means that the idea has probably got some traction already. Right? It could be full of shit. I don't know. I might build this for the next year and it turns out to not work because there's just too many foods, and once you start taking photos of foods, the dimensionality is just too much. But I don't care. I'm going to figure that out by actually doing it first. And think about it as this as well. There's how many self-driving car companies are there? Competition is good. It drives innovation. The same with, mine's going to be different because I'm building it in my way, right? That's why, well, not mine either. It's open source. The code is on GitHub. So Nutrify will be different because it's like, you can see it. You're going to see it being built. So that's like, that will be its like point of difference. It's like, hey, it's right here. It's all in the open. You want to use it, use it. And the same thing for, so that's, you can differentiate yourself by being authentic. And the same thing for books, right? There's 1,000 different biographies on Winston Churchill. Do you think author number 935 like was worrying about the other 934 books before? Maybe, maybe not, but they probably thought, I'm interested in Winston Churchill, so I'm going to write a book about Winston Churchill. So for me, competition is a good thing. If someone else has a similar idea to you, it means you're probably not that crazy. where is carbohydrates? But then again, it's also good to be crazy. Carbohydrates. Okay, so I think it's by difference. That's what we want. Let's look up another food. I'll go to food search and we'll look up a banana. Banana has carbohydrates. Chicken drumsticks makes sense to have no carbohydrates because meat doesn't have carbohydrates. Yeah, Virgos is 100% right. We are in a time where people are understanding what CV is capable of and finding ways of using it. Here, let me bring this Twitch chat into there. Yeah, we're at a good point of like computer vision, right? Computer vision algorithms are probably the best performing. Of course, you could argue GPT-3 is, but computer vision is just, it's getting very, very good. Like Tesla are building a whole self-driving car fleet off just computer vision. Of course, there's more. You need to do the planning and whatnot, the software 1.0, which will be for Nutrify as well. You'll have the computer vision part of it, which will be take a photo of a food, return a probability estimate of what the food is. But then you need the software 1.0 to link all of the data together and display it in a nice way. But Virgos is correct. CV algorithms, especially on devices, like the latest iPhone can do so many ML computations very quickly. Apple just had a great blog discussing how they use transformers on mobile, Apple machine learning. So this could be a future stream as well. Replicating this architecture. There we go. On-device pan-optic segmentation for camera using transformers. So this is how they use transformers on mobile, just performing insanely well. HyperData, that's their architecture, and it does segmentation masks. It only does for 6. My mouse just died. It only does it for 6 different classes. Sky. There. It does it for 6 different categories: sky, person, hair, teeth, skin, glasses, to enhance the photo. Now, who's to say that we can't do this for 1,000 different foods and segment those different foods? Now, if you imagine, models are only going to get better, data is only going to get more ubiquitous, cameras are only going to get better, processors are only going to get better. If you combine all those in 2 to 3 years, who's to say Nutrify can't identify the 1,000 most eaten foods on Earth in a way like this? I guess we'll see. But this is a cool article. Right now, we're early days. I'm still a noob at this. I'm literally trying to figure out how to isolate 3 nutrients from a database. Early days, team. We're here on early days. And I'm sad that my mouse just died. I got used to using that. Back to the trackpad. So I'm going to take carbohydrate by difference, I think. Banana. 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 We want, oh my gosh. Ripe and slightly ripe. Where did the chat go? Here. Siobhan says, I'm actually at a crisis trying to avoid competition, but we live in a world of abundance. The cake is big enough for all. Dude, Siobhan, you're totally right. Look how many courses there are on TensorFlow and whatever. But I made a TensorFlow course, and there's other courses out there. It's like, if you make something that's good, people will use it. Alessandro says that I hear about Google's Tensor. Yeah, now Google have their own chip. Yeah, see, this is what I mean. It's, okay, so by difference, I'm just going to get total carbohydrates. We can split fiber and non-fiber later on. Yeah, we can make the database more advanced later, but we're just going to get carbohydrate by difference. So we want Google's Tensor is very similar to our like Apple's custom chip. That's what companies are starting to realize now. Is like if you've got the money and you've got the engineers, it's probably better to build a custom chip for your specific use case, because then you can just optimize it for whatever you're working on. So nutrient, we want name equals we could do is in with this. Total lipid is fat. Name dot is in. So is in, I believe, would be helpful if you know what the columns are, what the names of things to begin with. Protein, total lipid, fat, or carbohydrate by difference. There we go, team. We're on. Fish on. So we need the nutrient IDs. There we go. We've got those IDs there. So target nutrients equals. Now, do we have carbohydrate by difference equals total carbohydrates? How does this mouse charge? USB-C. Fish on. We have a USB-C cable on hand. Is that charging? Carbohydrate by difference equals total carbohydrates. I want the data dictionary for nutrition. Nutrient. Nutrient. Okay. That's all right. We can find it later. Is it on the website? What each of these measures. Download data, data type documentation, Foundation Foods. Here we go. Carbohydrate. Here we go. It is expressed. This is well documented, this database. Carbohydrate content, referred to as carbohydrate by difference in the tables, is expressed as the difference between 100 and the sum of the percentages of water, protein. Values for carbohydrate by difference include the dietary fiber content. Carbohydrate. Okay. C, carbohydrate. Let's go back to our data analysis. See this document for okay, so total nutrients, let's move this up. I don't like that there's no up button in the VS Code. So if I click here and press escape, B, there we go. Target nutrients. So target nutrients are these three. Let's create a mapping. So target nutrient dict equals, we want ID 103 and then protein. We'll keep them all lowercase. And then 104 equals fat. And then 105 equals carbohydrate. Wonderful. So now we want to get, what other data frames do we have? Food nutrient. Yes, okay. So this is what we want. We want the chicken ID. Chicken wing ID. We need to get target food, protein, fat, carbohydrate. So food nutrient, target foods. We want to now index on the target foods and the target nutrients and retrieve their values for each food nutrient. E.g. food 1, this can be a dict of dicks maybe. Protein equals 100. Protein equals 100, and then we'd go carbohydrate. Shit. Carbohydrate equals 50, and then fat equals 20. And then ... We want this in. No, that will be the end of a dict. Then we'll have food 2. Okay, I think that will be fantastic if we can get that for our 10 target foods. Food nutrient. Now we want food nutrient FDC ID equals chicken wing ID. What do we get? So we get 95 rows But then we want the nutrient IDs equals one of these three values. So nutrient ID and yeah, Siobhan's has done fantastic building a Nutrify V2 with Django. You can even do a drop down here for the country. Choose file, upload image. Heroku, I need to figure out how to deploy apps to Heroku too. This looks brilliant, Siobhan's. Thank you so much. Please log in to check out community uploaded images. That is really cool. You've got login there. That way we could tie everyone could see their own images. And I thought of this for data labeling later on, is just have a carousel of like recently uploaded images, and then people can submit their own labels. And how would you prevent that from being hacked? Well, you wouldn't really, but you could just do like a run a few tests on the labels. Like say other labels, say if people upload 10 different versions of banana, like the word banana, well, pick out the most common words and filter out all the things that aren't food, like people uploading butt and poop and yuck and whatever. You could filter out every string that isn't a food and then use like label by consensus type thing. But that looks incredible. So let's now get nutrient ID dot is in you can do dict. What is in? Yeah, kind of like capture for foods. Yeah, you're exactly right. Pandas is in. You can do a dictionary. Huh. You can do dot nutrient ID is in target nutrient ID target. There we go. Now let's get the nutrient IDs from this. What? Is it not got, where's the carbohydrates and fats and whatnot? Let's map this. Let's add a column here. What's it called up here? No, that's not going to work. I need to match off Hey, Wei Yan Paya-san. Yeah, I'm going to do this. I'm going to do this fairly often. I'm glad you're enjoying it. There's going to be plenty more streams in the future. Yeah, Docker's going to come into it later on. I'm not sure about the Heroku dependency size. So we need to map, what have I even got here? Nutrient name. I want to create a column. This is what we have to do for pandas. I want to create a column nutrient name, which is going to map. I need to talk this out loud. I haven't done this in a while. So I want to map, I want to create a column name, which is the text-based version of nutrient name based on the ID here. So I need to index on nutrient. So equals nutrient where nutrient ID is equal to, no, nutrient, what are the column names in nutrient? ID, where nutrient ID is equal to these rows. Nutrient ID. No, that's not it, is it? We want nutrient ID get the IDs from here. So map, new column. Let's write this out in pseudocode. Map, nutrient name to food nutrient. Nutrient name equals nutrient ID. No, equals nutrient name where nutrient ID equals food nutrient ID column. So the nutrient name column equals the nutrient name. This is a string where the nutrient ID, this value here, equals the nutrient ID, which is this value here, nutrient. We're doing a join here. This is some form of join. Equals the food nutrient ID. So I want the string-based name here because I want to figure out what these. Could do this for the entire table, but does this make sense? This is going to error for sure, but we're going to try it anyway. Nutrient name, so that's this column, equals nutrient name where nutrient and then maybe error. Let's try and get nutrient Let's look this up. I've looked this up multiple times. Actually, I think I've got this in code snippets. I've done this plenty of times. I just can't remember how to do it. Create a pandas column based off another column. That's what we want to do. Val or not class name. Map. In pseudocode. Thank you, friend. Thank you, past me, for adding Code snippets. So pseudocode, we want df1 new column. Let's just do the whole thing. Food nutrient, nutrient name equals df1. So food nutrient. Match a column will be the nutrient ID dot map on the other data frame, which is nutrient set index match a column, which will be ID, and it will be new column will be nutrient name. Will this error? Method is not subscriptable. What did we get wrong here? Oh. Key error. Oh. Oh. Note, match a column and new column for df2 may have different names, but will work as long as they have the same values. Different column names. We're on team. Look at that. Pandas, baby. We've got nutrient names along all of our rows of food nutrient. And now we can get rid of the pseudocode. And now we can get the chicken wing ID, because we're going to find out the nutrient names here. Let's move this down. Let's move this down. We get our nutrient names on the side here. Doesn't that look clean? Looks very clean to me. This Notion, you know what? It's actually not that verbose, but I just put, if I find myself writing something over and over again, it's only like 20 lines of code here. But I should make it more verbose. Can I make this public? You can have it. But that's what I feel like a code snippets is. The importance of code snippets is that you create them yourself. Why? That way you know what's in there. Or at least you can try to remember what's in there. So that's like when people ask, how do I take notes? Or how do I write down what I remember? It doesn't matter how I take notes. Of course, you might pick up tidbits from me, but ultimately, for you to remember something, it's going to come down to you. That's the value of a database, is not necessarily having all the information. It's if you can know where to look and if you can find it. I set it up. Each one is in like its own Notion page. So it's just like get a list of projects in G-Cloud projects list. Setting your commit. So commit email address in GitHub. Install packages line by line in requirements. This is what I use a lot actually. Install Conda package to current environment from within a Jupyter notebook. This is very handy. How to install a package from within a notebook. This is one I've used a lot. That's why it's there. That's why I knew it was there. How to install packages line by line in requirements.txt. Vim commands. Stop word list in Python. Google's Python style guide, create a new TensorFlow environment. You're right, creating a blog post, those could all be worthy of blog posts, like tiny blog post. Or GitHub like gist or something like that. Where were we? Let's go back. We're making progress here, team. Now, why is nutrient name not... Oh, it made a cell up the top again. And some days I look at you do. I got that song stuck in my head. Escape here, press B. Boom. Okay, we want to know why isn't protein in there? And nutrient name, do we have protein here? Equals dot string protein case equals false. We do have protein. Why didn't that show up before with nutrient ID? Food nutrient is in that didn't work. Oh, are they strings? Is that what's wrecking this whole thing? What? No, it's not summary. Is it summary? Info. No. How do you get all the data types of a column? Describe. That's it. No. D types. Okay, there we go. Nutrient ID is an int64. And why isn't this? Oh, they're strings. Damn, son. We want... I've turned them into strings up here like a moron. Like a moron. Dictionary keys can be ints if they want to. Oh, holler at your boy. We should be on here. Nope, still not on here. Nutrient ID. Oh, I've turned it into a list of lists. There we go. Holla at your boy. Holla at your boy. Then we can bring in our little, we don't need that. This is some great EDA here. Very fun. Some days I look at you and nutrient ID. This is where we can, this is the magic moment. The whole stream has been dedicated towards finding the nutritional value of a chicken wing. I hope you realize that. We've spent this entire stream programmatically figuring out the carbohydrates, protein, and fat of a chicken wing. Boom. Holler at your boy. There we go. We've got nutrient IDs for a chicken wing. So in 100 grams of chicken wing, you have 5.9 grams of fat. That sounds wrong. I thought that would be more. And you have 23.9 grams of protein. But we're on. Fish on, team. Fishing video. That's what we should look up. I should get an emote that's like a celebratory fishing video. So now we have the chicken wing ID. So we can create, we might create a sub dictionary. Should I create a dictionary? How could I structure this data? This is holler at your boy. Find nutrition for chicken wing ID. Protein, fat, carb. Now we need to do the same thing for our other foods, which is food list. Oh no, 10 foods. So we've got chicken wings. I'm thinking a dictionary of dicks. A dick of dicks. To store. I like the dictionary of dicks. Like a list of dictionaries that contain dictionaries. I like that. We use Python standard style. So if we went here, I want to suck the information out of here. Let's put it into a, should we put it into a frame first? Let's create a map, a dictionary of 10 food IDs. And so we want to go chicken curry, but chicken curry doesn't exist. So that's our problem, right? Is chicken curry doesn't exist in this database. Or does it? So if we go back, it's all high level foods. SR legacy foods. So let's search chicken curry. Nothing. Branded foods. Oh, hold on. Chicken curry, team. We have a lot of different chicken curries here. Let's go the bland chicken curry. Imagine if they had chicken curry. Ingredients. Generic chicken curry. Hey, hey. Pressed canola oil, sadness. Deep sadness. See, that's going to be hard. The nutrition information about, this is Mr. Kook's. I like that. Mr. Kook's chicken curry. Mr. Kook's. Jeez. Thanks, Google, for showing me that site. Look, would you eat that? This is Mr. Kook's chicken curry. Now, I believe the information on this would be based on the brand itself. It's a source rather than... Okay. Label Insight, USDA database. Oh no, this is... What do we got here? Another... The world's leading product attribute. See, these websites are... What do you do? Good. Where's your data? Where's your API? Here we go. How much are you going to cost me? What the hell is this website? Oh, QR code. I don't want a QR code. I want ML. Give me... People are liking QR codes though these days. That would fix a lot of things, is if you just QR code it. So this website gives you, it's just a placeholder for a QR code. Someone scanned a barcode. I don't want that. I want to take a photo of a chicken curry and understand what goes into it. So maybe we're going to have to readjust how we do this. Chicken curry with rice. Hold on. Branded foods. This is what we want. Survey foods. What does this take us to? Chicken curry. Is this a sauce though? Because there's got to be more. That's what you could have. Is this wrong? Yeah, you're right. This is the same thing. It's more just the... Okay. So we need to stick to just whole foods, I believe. That's what Nutrify V1 will have to deal with. It will just have to deal with whole foods and not dishes. Dishes add a lot of complexity. So let's change our 10 foods. Wow, a lot of them are... A lot of them are dishes, aren't they? Well, let's go to let's have a look at our foundation foods. Where do we have our foundation foods? There we go. Okay, maybe we want beef. Animal 18. You tell me there's another ID that I have to... Maybe this is why people haven't done this yet. Because there's so many. The dimensionality just kills you. Look at this. Producers. Liquid egg white. No. Whole foods. Yes, you're so right, Siobhan's. Periodic table of foods. Pickles. Peanut butter. We could pick 10 whole foods from here and just start with that. How about we do that? Let's create a new list. 10 foods. Let's rechange 10 foods to be 10 whole foods equals what? Who wants to pick some foods? We've got one is chicken. Chicken wings. Ten whole foods is chicken wings, which aren't really a whole food, but we'll do for now. Chicken wings. We'll go back to here. Could we do milk? I like milk. We're going to start with, yeah, whole foods is much smarter option than going towards why don't I just go to banana? I'll go to my fridge and just think about what's in my fridge. Yeah, let's do that. I'm going to go to my fridge and look at what's in my fridge and literally just do that, because that would be cool to have like a demo of just taking a photo of what's in my fridge. Okay, Siobhan said take a photo, please, but I didn't take a photo, but that's all right. I can tell you what I have. Well, these are most of the whole foods. Blueberries, carrot, eggs, whole eggs, of course. Like I'm not storing eggs in liquid form in my fridge. Well, they're in their shell, put it that way. Steak, mushrooms, strawberries, yogurt, milk. So let's sort this by alphabetical order, hey? Put my phone down. Foundation foods is a list. So we want to sort. Is sort just a built-in Python? Sort. How do I sort a list in Python? Python sort list. I thought it was sort. List.sort. Sorted. Thank you. Foundation. Oh, we want it as a list. List. Thank you, Siobhan's. What would I do without you guys? There we go. Okay, this is much better. Much better, much better, much better. So, what do we want from here? I've got bananas. Apple, why not? Because apples are there. Apple. Beef. We want beef. This can be steak, etc. Obviously, it's going to be different for different cuts. Carrots. Yes. Frozen. Why are the only carrots frozen? There's no fresh carrots. Oh, butter. I could do butter. Okay, we might need more than 10 foods. Carrots. We've got chicken wings. Egg, whole. Egg. Egg white dried. Egg whole dried. Whole egg. The prototype has to launch with like at least 100 foods, I reckon. So we could just go the whole hog of what's in here. What else did I have? Do they have... They don't even have blueberries? Bruh. Berry. Strawberries. They have strawberries but not blueberries. Okay, team. Strawberries. What's going on here? Why don't they have blueberries? Blueberry. Blueberries. Why is this not a foundational food? This might be in subset of food. Okay, so let's go back to our data exploration. Where did we create foundation foods? Foundation foods, let's go up. I want your berry. Sample food, okay. Blueberries. Where are blueberries kept? We're on the quest to find blueberries now, team. I love this so far. We've just been food. Oh. Why does food equal that? Where did I reset food? Food. We're going to find blueberries. See, this is what we do, right? We pull the little trick. Market acquisition. I have a feeling it might be in market acquisition of the data type. Food description. We want food there equals no, string dot contains blue case equals false. Come on, man. Food. I need to set food to equal to drop NA. Contains. Okay, we have a lot of almonds. Contains berry. They got something against blueberries, man? Well, I know they don't because it's in the database. Show me this as a list. What? They don't have blueberries. Food. 27,000 types of food. Where? They don't have blueberries. It's all strawberries. This is a hoax. The quest for blueberries. Survey foods. Download data. What did we download? Foundation foods. Ah, okay. So we're in... We didn't get the survey food. So if we go back... This is what we just found out. We're finding out things that there's more than one database. FNDDS. Okay, so there's more foods in the FNDDS. Blueberries and other berries. Graph structure type. I think you're right. This is... I don't know enough about graph structure type data. I think it might be relational though. It's still relational. So... Looks like blueberries and other foods are in the survey data set. We've discovered where the blueberries are. I'm going to take a note in Notion. Nutrify. Building a data flywheel. So this is the log. I did that today, exploring data from USDA. Blueberries are in survey dataset. This means other foods are probably there too. See here for building a data base of nutrient values for 10x different nutrient values. This can be protein, how many windows don't we need? A lot. Oh, that feels good. To clear all those tabs. Get rid of that. Don't need that. Okay, back to where we were. What other foods do we want? I kind of want blueberries. So let's just put it in there so it forces us to have to explore some more data. Blueberries, and then we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Yogurt. Eggs are a good one. Milk. See, yeah, you're right, Shavans. There is, look at this. So there is 8 different types of milk, or whatever that is. So that'll be interesting. Got mushrooms there, got kale. Obviously this is very biased by my own food choices. Butter, beef, apples, bananas. What else did I have in my fridge? Mushrooms, we could do mushrooms. Let's do mushrooms. Mushrooms are a cool food. Mushrooms, and obviously there's a bunch of different mushrooms. We're just gonna have to pick one. And then Shivans, what food do you reckon? Onions, oil, peanut butter, oranges. Peanut butter would be cool. Yogurt. You pick a food. Kale, garlic, peanut butter. Done. Honey is a great one. They have honey? They don't have honey. I wonder if they have honey here. No honey. Honey is categorized in sweets. I mean, honey is sweet, but it's... Rasham, how are you? Yeah, let's do honey. I like honey. Okay, we have a pretty diverse... Let's find out where honey is. Honey's in the survey data. How do we download the survey data? Rasham, what's going on, my friend? This is a CSV of 5 million. Whoa. 213 million items on this one. This database is actually kept up to scratch. Okay, we're downloading this. Oh, Rosham, Shem. Attention mechanism, that is a great option. Oh, wow. You finished your final year project from the TensorFlow course? We'll open this up. Okay, we're going to bring this in. Massive effort, Rosham. That's really cool to hear. So we have food, CSV. Oh, it's only 630 kilobytes. Nutrient is only 25 meg. They're relatively small. But do we have blueberry in here? Oh, that's fantastic. I love Streamlit. Delete. Okay, look how many types of milk there are. Oh, goodness gracious me. I haven't tried using Dash. I actually really haven't heard of Dash. Blueberry. We have blueberries, team. Blueberry pie? What about just blueberries? Blueberry syrup? Or blueberries? Blueberries raw. We're on. Boom. Have I tried using Dash? What is Dash? Do you have a link? Dash Python. Oh, it looks quite similar to Plotly. Oh, that's cool. Yeah, for me, Streamlit looks far easier to use. There's a lot going on here for me. But that does look very good. Okay, so now we've just added another data set to the mix. What columns do we have in here? Oh, we just have food ID and names. Okay, good that they are all on the same sort of structure. They have FDC ID. Survey finds food is the data type. We go back to our food database here. Description. Food category ID, publication date. Okay, they have the same. We could append them. We could append them to be the same data set. Ten Whole Foods. How could we functionize this? Where were we last at? We just had the... Okay, so this is the nutrition for the chicken wing. We need to get a mapping of our 10 Whole Foods and their IDs. And once we have their IDs, we've got the nutrient IDs. Let's do that now. So let's go back to today, write down our steps. Let's go this. Changed to Whole Foods. Easier to begin with. I can't believe we had someone from a university working on the same problem. Ten Whole Foods. This is what we're doing. Okay, we want I want to put the next steps in here. Next, map 10 Whole Foods to their unique food ID. Get nutrients, protein, carb, fat for 10 Whole Foods. Now I believe everything except blueberry and honey are in get food ID. everything except blueberries and honey are available in Foundation Foods. For blueberries. Survey data, which is at survey. So let's put that in Notion. So let's get everything except blueberries and honey, hey? And I know that's cheating, but whatever. We'll get blueberries and honey tomorrow. Machine learning extension crisis. Feet chicken wing. That's funny. Get all food IDs from Foundation Food, honey and blueberries in another data set. So let's get 8 whole foods. We'll find Foundation Food. Wonderful. Now we want to go through this data frame and say Foundation Food, let's filter out. We've already got chicken wings. Can I see all of these clips on my channel? Twitch.tv. Where do you see clips? Mr. D Burke / clips. Hey. Okay, we can see the clips there. Thank you, Shavans. Let's get out of numbers. We don't need numbers. We want, oh, I'm in the darkness now. Hello, I am in the darkness. We need the real hacker look. Should put a hoodie on. Foundation food equals description. String dot contains. We want apple. There's all the apples, but we got to pick one of them. Red delicious. Yes, you're so right, Rosham. Every food is separated with a different ID. This is a MacBook Pro, Rish. Mr. Robot. Yeah, oh, I love Mr. Robot. You're right, my new home does not have a TV. So, can we programmatically pandas check if a column contains string from a list of strings. There we go. Oh, it accepts a regular expression pattern. Holla. Is my mouse back to working? There we go. I like this. We can use regex. So let's Stack Overflow on the right and code on the left. So we've got a pattern here. We actually don't want chicken wings. Let's just use that. We'll get rid of that. 8 Whole Foods. Removed chicken wings. Can come back later. So let's go. Okay, we've got a list, 8 Whole Foods. So we want pattern equals dot join. We'll F string it up for, it doesn't matter if it's capital or not. We want food. food for food in 8 Whole Foods. Pattern. Nice. Okay. Let's see how this goes. We want pattern. Oh my goodness. Look at that, team. We got mushrooms. We got bananas on deck. We got eggs, y'all. We got sausages. We got carrots. We got beef. We got eggs, more carrots. We on. Fish on. Let's share this. Copy link. Let's upvote that. Already upvoted that. Upvote that. And we go here. I didn't know that. You learn something new every day. The string contains can search on regex. So foundation food. Now we've got some IDs here. We just need to pick which ones we want. I want to sort this on sort by description. How do I sort a data frame? Is data frame just sort, or is it sort by? I just leave that link there so I can come back to it later. Pandas sort data frame by column. Sort values. I knew it was something sort. By. By description. Oh, look how clean that looks, team. Boom. I'm going to save that Stack Overflow in Notion. Code snippets. This is how I do it. Filter a pandas data frame based on a column that contains a string within a list of strings. I have a list of strings and I'd like to return all rows from a data frame that contain a string from data frame column from within that list. Pandas, Python, link. Sort pandas data frame by column containing string from list of strings. Create embed. I like that. We'll come back to that later. Maybe. Where were we? Pandas. Sorting values. Come back. Look at that code. That looks beautiful. Okay. So now we can start to map. Which egg do we want? We want the whole egg. Just the whole egg. Egg whole dried. Map foods to food ID. 8 Whole Foods ID map. We want it in alphabetical order, don't we? Obviously, we're going to productionize this later. Yeah, this is just a view of this data frame though. It's not a copy. Well, it could be a copy, but this is just a view. I'm not assigning this to any variable. This is just a view of the original data frame. ID food. So apple going red delicious. There's 2 red delicious with skin. 2 of each apple. Why is there 2 of each? Let's search apple. Foundation food, apple red delicious. Okay, I'm guessing we should use the later number. Apple Gala. Yeah, 17. Okay, we'll use the later number. I'm going to do red delicious here. Apple. Red delicious. These have been filtered from five different, from larger quantities to smaller quantities. For example, if there were 5 kinds of apple, only 1 was chosen. Banana, we want slightly ripe and slightly ripe, raw. What's the difference between those? Let's look up banana. Ray JU, how are you? Good to see you. What do we got the difference here? About 20 grams of carbohydrate in a banana. Yeah, that makes sense. Overripe. Much difference to this? About 20 grams. Not too much difference. And now for beef, we're going to use, well, I have T-bone steaks in the fridge. Let's have a look at that. Steak. Yeah, so this is the pandas index column here, and this is the unique food ID column here. So this is just the pandas index. What's been happening? Well, we're working through Nutrify. We're doing some data exploration of the FoodData Central database. which is just a big database with all different information about different kinds of food. And what we're trying to build here is a small little database with information from the US Department of Agriculture on what different kinds of food contains, so that we can build our full-scale machine learning app. You can take a photo and learn about it. So take a photo of different kind of food, and the computer vision model will return a certain image, and then the nutrition information will get displayed about that food. So I'm going to use steak for... Okay, so T-bone steak. I believe it's the later number that we want to pay attention to. Yeah, so, for some of them. T-bone steak. We're going to use the T-bone steak. Well, that can be beef. This is T-bone steak. And then for carrots, frozen unprepared. Carrots, frozen unprepared. Rosham, we're going to use a similar data set to the one we used in Food Vision. It will have to be customized based on the information we have for different foods. The Food Vision data set started with a lot of different meals. So this application is probably going to focus on, well, it will focus on, to begin with, just whole foods. So like an egg on its own rather than inside a dish, because as you can imagine, a machine can't really do what a human can't do. So if a human can't look at a dish and go, oh, it has all those ingredients, well, can you really tell that from vision? Maybe, eventually. But to begin with, we're going to keep it simple and start with whole foods. So egg. Egg. We're literally doing like, we're in the trenches here with machine learning. Mushroom, shiitake, or white button. We're going to do white button. Everybody want to build state-of-the-art algorithms, but nobody want to spend hours trudging through a database, creating a database for their problem. Nobody want to do that, man. Mushrooms and now strawberries. Take the later one there. Strawberries. So this is strawberries raw. And this was mushrooms white button. And then we have chicken wings is going to be back up here. Chicken wing ID. Chicken wings, and then we want, we'll put in here chicken. There we go. Do we have chicken? Yeah, there we go, the drumstick. Boom. Thank you, Eric. So you're starting to see, I appreciate that. Eric says this part is super enlightening. Also, it makes it easier to figure out problems down the road since you know the database very well. So yeah, the machine, once the data, as you've probably experienced, once we've got the data in a formatted way, building the model is relatively easy. Of course, you can always make the model as complex as you want, but how much better is building a model when you've got just a folder full of images ready to load into TensorFlow or PyTorch? So this is what we're doing. We're starting small. We're getting a small data set. We're making sure that the pipeline works. And then as our prototype starts to work and people are using it and whatnot, then we can start to add complexity as we need. But if you get too far ahead of yourself at the start, you're going to have way more errors than what you need. So let's just become one with the data, really figure out how this database works, and then later on, all this hacky code we can fix up and make it work a lot better for hundreds of foods rather than just 10. But that's how you start with things. You do like 10 handcrafted classes, and then you write code to scale it up to more custom classes. So we got the chicken wing food before. Let's see if we can do the same for... Where's our chicken wing? Here we go. So this fine nutrition for 8 whole foods. So let's have a look at 8 whole foods. Let's get those keys. Eight whole foods ID map. Keys, and we're going to turn that into a list. Wonderful. So this might be a magic moment here, team. A magic moment. You ready? Boom! Look at that! Woohoo! Holler at your boy! We've got the food nutrition information for our 10 foods. How cool is that? What do we have here? Length is only 24 because we have 3 nutrients for 8 foods, and we're on, team. We're on. Food nutrient. So I want the food types next to that. That'd be much better, wouldn't it? Whoop, whoop. No, oh wow, no dinner tonight. I'll probably go have some dinner soon, but whatchamacallit, yeah, I didn't realize it's 7 p.m. But that's all right. I'm not in a rush. We've got some good information here now. Let's get some. I'm sick of seeing these codes. No, let's turn this into a. What can we do for this? We can turn this into a. Let's group by. No, we can turn this into. What's the table called? Table called pivot table? No. Is it? A pivot table, will group it on ID and then group it on nutrient ID. No, index. A double index table. That's what we can do. Double index data frame. Index data frame on multiple columns. Multi-index. This is what we want. No. Multi-indexing. Pivot table, pandas. Maybe we group by because what structure do I want this to be? Because I'd like food, food ID, food name, food ID, protein, carbohydrate, fat. Something like this. Something like this. The ID columns are all right. That's actually all I want. I want those three. There we go. There we go. So now I want to move the nutrients up into here. So protein, carbohydrates, fats. And then move their amount up there as well. Move their amount into here. There's an easy way to do this, isn't there? Pandas turn There we go. That's what I want. Pivot table. This is brilliant. So they have number of metals. Nice. 8 Whole Foods DF. I don't need the... Yo, Ashik, what's going on, man? Okay, I know what I need to do. Well, I want to remove this and just drop those down. Hey, there we go. Boom. That is exactly what we wanted. PyTorch is very similar to TensorFlow. Oh my goodness, team. Look at us go like beast. Beast mode. See, look how many times I've been here before. There we go. Look at that. We got to where we wanted to get to. How long did that take? Nearly 4 hours. Should I do more YouTube streams or should I keep it on Twitch? This is what I have a larger following on YouTube, you're right. But would that clog the channel if there's just live streams galore? Or should I just keep live streaming on YouTube and just say whatever? But look at this, team. We have a little database of different foods and their macronutrient values. So we've got the code in place. The next step is to add blueberries and honey to the database above. And then we'll train a model on the 10 foods, integrate models somewhere to show off the nutrients in each food. Beautiful. So, yeah, let me know future-wise. I think I'm going to stay on Twitch, but let's go to this. This is what we want. We got that. This is a good stream. For 10 whole foods. Almost. I have to do 2 more foods. So tomorrow or whenever the next stream is, we'll continue. We'll do blueberries and honey. Maybe that'll be, I'll do that behind the scenes. I'll clean up this code. And then we will start to build the first version of Nutrify. Let's get out of all these. Let's go here. But we got very familiar with the database. So where's the repo? Nutrify. This is where we're going to next. And I'm thinking about doing a celebratory stream. We might do this in a big stream for 100K on YouTube. Stage 2. Let me know if you'd like to see that. We'll do that all in one big stream. Stage 2. Build a computer vision app on these 10 classes, just 10 classes. And then by the end of the stream, we want to have a deployed app which you can take a photo of one of these and it will display the nutrient information. Beautiful. Okay. I think I'm going to do that on YouTube though. Big celebration for 100K. So thank you all so much for joining in. I'm going to add the code. Actually, that's the last step before we finish. Is let's add this to the GitHub. Git commit, update, data exploration code, plus add new dataset. Git push. That's going up. We can go up here. There's all the code. Data exploration. ML part will probably come within one of the few next streams. We've got to start collecting a data set. Well, actually, maybe not in one of the few next streams. We still have to collect a data set of images. We'll see. Just stay tuned to the streams. I'm not sure what order things are going to come in. We just kind of take down things as they come. But let's also finish off the log here of what we've done. We want the log, and that is we explored USDA dataset and found a way to map food names to their nutrition values. Created a small database of 8 foods and their protein, fat, and carbohydrate. Hydrate amounts. So this is some good progress, I reckon. And then we want to write here B. Oh, I don't want a new page. Next. Finish. Finding macronutrients for blueberries and honey. Collect food images. Oh no, clean up data processing and exploration code, and start collecting images for 10 base foods to build stage 2 app. All right, we're on. Beautiful. Okay, so thank you all so much for joining in. At the start of this stream, we had 0 cells run in this notebook. We've had 400, close to 400 code cells run this session. So a lot of fun, a lot of learning, and I will see you in the next stream.